In the last part of this video, I want to relate gravitational potential energy to work. So what we have here is work done by gravity, and I use this to help explain this concept here of conservative force. But we have that gravity does work on an object as it falls, and we're given that the amount of work that gravity does is equal to mgy initial minus mgy final. And we learned that mgy would be the initial potential energy, and then mgy final would be the final potential energy. So we have an initial minus a final. So usually when we use delta, that's always going to be final minus initial. So if it's initial minus final, that's why we have a negative in front of the delta. So without deriving this equation, we just want to make sure it makes sense. Okay? The work done by gravity, it makes sense that it's related to the potential energy because work is force times distance. And the force is mg, and the distance is y. So it makes sense that it's going to be mgy. And it also makes sense that it's going to be the initial minus the final rather than the opposites, because we know that gravity does positive work on this object, right? Gravity is pulling down, the displacement is down, they're in the same direction as positive work. We also know that the potential energy here, PEG initial, is more than the potential energy here. The higher you are, the more energy you have. So in order for the work to be positive, we definitely have to do the initial minus the final to end up with a positive number. So again, I'm not deriving the equation, I'm just showing that it makes sense. So why do we care about this equation? Well, it lets us talk about very briefly about this topic of conservative force, which will come up again if you take physics 2. So gravity is this special type of force called a conservative force. That means that it doesn't depend on the path taken. It doesn't matter if your object falls straight down or if your object was on a slide, on a frictionless slide and sliding down this way. Gravity would always be a force downward. The displacement, no matter what your path is always from this top position to this bottom position. So the same work is going to be done no matter the path. The fact that gravity is a conservative force is important because conservative forces always act to reduce the potential energy. This is something that we're going to see again once we start dealing with springs, and that you're going to see again in electricity and magnetism in physics 2. So if you kind of make a note of this, that conservative forces act to reduce the potential energy, if we accept that gravity is a conservative force, well, we know that gravity wants to make this book fall down. As the book falls down, its energy decreases. That's all that this is saying, that the gravity is trying to reduce the gravitational potential energy of the book because it's a conservative force. We'll table this for now, we'll come back to it later. Let's do one more your turn for this video. A woman pulls up a crate up a rough inclined plane at constant speed. Which statement is not true? A. The work done on the crate by gravity is 0. Well, that's not true. So that already answered the question that A is not true. We know that this is not true because if we have an incline, gravity acts downward, even if you're pulling this thing upward, gravity has that component to the left, to the right here, this FGX, that does negative work on the box because it's in the opposite direction as the displacement. So it does negative work. So that's not true. So that's actually the answer. But we can go really quickly through the other choices to see that these statements are actually true statements. All of these are true. So B, the gravitational potential energy is increasing as the crate pulls up. That's true because as it's being pulled up, it's gaining height, so it's gaining potential energy. Part C, the work done by the net force on the crate is 0. This one's harder to know. That is true, but it's true because It's being pulled up at a constant speed. We've learned that's a key word. Constant speed, you think equilibrium, the net force is zero. Well, if the net force is zero, then the net work is zero as well. And part D, the work done on the crate by the normal force is zero. That is true. The normal force acts perpendicular to the surface, so we learned that a perpendicular force does no work. So just to recap this video, we talked about gravitational potential energy. The main thing is the more height you have, the more potential energy that you have.